Hello students, now we will discuss about digital and analog pins. Students will be able to understand about the concept of digital and analog pins as input and output. Analog visits digital. Microcontrollers or digital devices on or off, also called discrete. Analog signals are anything that can be full range of values. These are the digital pins on an Arduino UNO board. Digital pins. A digital pin can have only two states, high or low. Low means 0 voltage, high means 5 voltage. You can consider them as binary pins. Low means that the voltage on the pin is 0 voltage, high means VCC, which is 5 voltage here for Arduino UNO. Digital pins as output. When a digital pin is configured as an output, it can be used to send signals to external devices such as LED, motors or any actuator that can be controlled electronically. Configuration. Use the pin mode pin comma output function to configure a pin as an output. This setup allows the pin to output either a high or low signal. Example, pin mode 13 comma output. 13 means pin number. Operation. High signal sends a voltage, usually 5 voltage, to connect the device, effectively turning it on. Low signal means sends no voltage, that is 0 voltage, turning the device off. To control an LED connected to pin 13. This is the program to control an LED which is connected with the pin 13. Circuit diagram description. Arduino board. Any compatible Arduino board, example Arduino UNO, LED which is connected to the digital pin 13, resistor 220 ohm to 1 kilo ohm which is connected in series with the LED to limit the current. The connections will be anode will be positive of LED, pin 13 of an Arduino, and cathode of an LED is connected with the resistor and it is connected to the ground of the Arduino. And the circuit diagram to blink an LED is shown here. To read a button state connected to pin 2. The program for to read a button state connected with a pin 2 is shown here. Reading analog quantities. Reading analog quantities with Arduino involves using the analog pins on the board to measure varying voltage levels from sensors. This process is crucial for interfacing with analog sensors such as temperature sensors, light sensors and potentiometer, which provides a range of outputs rather than simple on-off signal. This is the analog pins A0 to A5. How the analog pin is working. First, it will receive an input voltage and read this voltage. Let's say the pin reads 2.4 voltage. Then an ADC, analog digital converter, will change the analog value into something your Arduino program can understand the digital value. Arduino UNO board has 10 bits ADC. Resolution is 2 power 10, that is 1024. Thus the value you get when you read data from analog input pin is between 0 and 1023. Using analog write LED pin duty cycle is the same as digital write LED pin low, and analog write LED pin duty cycle is the same as digital write LED pin high. Duty cycle which ranges from 0 to 255. Example, analog write open bracket LED underscore pin comma 0, analog write open bracket LED underscore pin comma 120 close bracket, analog write LED underscore pin comma 255 close bracket. Steps to read analog quantities. First one is configuration. Connect the sensor to the analog pin, that is example A0 pin of the Arduino. Ensure that the sensor's ground and power connections are properly set up. Second one is code setup. Use the analog read pin function to read the voltage level from the specified analog pin. This function returns a value between 0 and 1023, corresponds to the voltage level from 0 voltage to 5 voltage. example code. This is the example code to read the sensor values. Circuit diagram description. Arduino board. Any compatible Arduino board, example Arduino UNO analog sensor connected to the A0 analog pin 0, power connections VCC 5 voltage or 3.3 voltage from Arduino, VCC for the sensor, ground of Arduino, GND of the sensor, signal connection, sensor output analog, A0 pin on Arduino. This is the circuit diagram represent the potentiometer. Running code of the Arduino. Upload the code to your analog board. Open the serial monitor in the Arduino IDE to see the readings from the sensor. Practical applications. As you change the input, example by adjusting a potentiometer or changing the light level on the light sensor, you will see the sensor values change in the serial monitor.